Bene, allora,
Good afternoon, everybody, and welcome to this meeting titled Industry 4.0. I would like to greet Mr. Perego, the director of the Industrial Engineering Department of the Politecnico University of Milan. It is a scientific director and founder of the Osservatorio of Digital Innovation. Then Andrea Pontremoli, CEO and General Director of Dallara. Up to 10 years ago, he was the youngest president of another important company for Italy and Southern Europe. Thank you for being here. And then Giuseppe Ranalli, the CEO of Tecnomatic Group, and he's in charge of the automotive area productive plant of the Abruzzo region. I have prepared a presentation for this kind of session, but since it is a complex topic, I am glad that we have specialists here. It's not easy to define 4.0. We only know that the words came out for the first time in 2011 in Hanover during the exhibition, and it was pronounced by some German experts because they wanted to stress the fact that we are experiencing a sort of a revolution. The first one was the invention of the steam machine, then the automation of industrial processes from 1890 onwards, then the connection between automation and the digital sector at the end of the 1960s, and then we are now experiencing Industry 4.0. I wanted to organize this meeting because it is a very important meeting for the future. This topic is being dealt with rather superficially. Many people talk about it, but I have the impression that not many of us really know what we're talking about. There are lots of fears, and there is in many instances confusion between productive processes, artificial intelligence, and so this meeting would like to aims at clarifying the concept, talking about the impact of Industry 4.0, and then bring you a couple of experiences, concrete experiences of what's happening. So I will now leave the floor to Alessandro Perego, and he will make his remarks on this topic. And I will tell you that normally I need to introduce the companies of the guests, but this time I will not do it. I will leave this task to themselves. They will introduce their own companies. You have the floor. I have some slides to show you. First of all, good afternoon to you all. As Bernhard said, the topic is very interesting, and it is at the same time sort of frightening. I see that there are at least three stances which define this superficial attitude. Those who minimize the phenomenon, they tend to say it's not the fourth industrial revolution. It is something which has been done for several dozens of years, decades. Then there is a second attitude, those of the optimist people, those who rather superficially, without an in-depth analysis, strongly believe in progress, and they only see the positive aspects. Then we have a third attitude, that of the pessimists, those who are essentially afraid. And so we shift from the position of those claiming that robots will steal jobs to those who state that robots will dominate the world. The correct position, the correct stance is that of being realistic. And so we should enhance and valorize positive aspects, but at the same time highlighting the negative aspects. So what we are talking about, I've prepared a short presentation with some key elements. First of all, we need to clarify what we mean by Industry 4.0. Then we should clarify the situation in Italy. And then I would like to give you some remark on the impacts that may be felt in the employment sector. Let's start from the definition. Can I have the presentation layout, please? Thank you. Well, we are experiencing Industry 4.0, recalling that this may be the fourth industrial revolution. The word revolution should not be misleading. The previous revolutions did not come about in just a few years. They came about and spread over several decades. All the previous revolutions, for all the previous revolutions, it took several decades. So this is the time span, the time horizon we should have. And then the second fundamental element, whether this is a fourth revolution, well, this has to be proven yet. We have the beginning, we have the prerequisites, but the future will prove whether this is an industrial revolution or not. These are the key features of Industry 4.0. The topic of interconnection. So the underlying idea is that of imagining a scenario of a productive system where the key resources, machines, installations, raw materials, and first of all people, and then finished products up to the final consumer are all interconnected. The key word is not automation. The key word is interconnection. So we're talking about an interconnection which touches upon not only the factory. And here we have another mistake, that of mistaking automation in the factories with Industry 4.0. But the factory is a part of a complex system, and it has to do with the smart life cycle and then the smart supply chain. So all the stakeholders, all the actors involved, creating value and reaching the final consumer. And they touch upon not only the manufacturing of the product, but also the processing and development of new products, the post-sales assistance, marketing processes related to consumers. So interconnection is one of the key production resources along several directions. And this is possible thanks to the convergence of two different types of technologies. On one part, we have the evolution of technologies for the production processes, robots which collaborate, robots able to collaborate with men. Then second hint, new man-machine interfaces, so that the worker can have a more powerful interfacing with the machine. Then the third element, the so-called addictive manufacturing. So the possibility not to produce product because of taking out material, but because you add material. For instance, with the 3D printing. And then we have the part related to the information technology, which is linked with the consumer world. These technologies, and here you have the three key categories, the cloud, manufacturing, which enables us to have calculation resources, software, even if we do not possess them in our factory, because we find them in the cloud. Then the Internet of Things, in which machines, people, and objects have sensors able to identify objects, able to measure functioning parameters, the status of the activity of objects, and then transfer this information to a following state, the state of big data analytics, namely the ability to extract knowledge from this enormous mass of information. So the convergence of all these technologies and the reduction of costs associated make it possible to have Industry 4.0. So interconnection between the key resources of the production process. What emerges is a scenario that I can try and describe you as follows. Imagine a supply chain in which the key production resources, men, machines, and products are all equipped with sensors so they can localize people, measure their state, their conditions, then transfer all this information to big data analytics. This takes out knowledge from data to improve the performance of the system from the point of view of safety, efficiency, and continuity of functioning. Imagine a system in which people are enhanced in their ability to interact with new man-machine interfaces or collaborative robots. Imagine that all this information is used to improve the processes, not only the production process, and not in the first instance. Imagine there are information on the use of products at the final consumers, which can return to enhance the development of new products. The potentials to be a revolution are all present, to be honest. This whole of set of technologies can not only improve productivity of work, so they can continue along a path which was started several decades ago, that of replacing some human activities, for instance, unsafe, insecure human activities, with machines, with automated activities, but also acting on other elements, for instance, the productivity of the other resources of the production system, consuming less raw material. This is an example, or managing better the life cycle of products. Implementing new business models, for instance, a circular economy, in which you can reuse resources, or sharing economy models. So the potentials for this to be the fourth industrial revolution are all there. But of course, we do need to demonstrate everything. Let's have a look at the current Italian situation. Some elements for the context. Italy is the second European country when it comes to industrial production after Germany. It ranks 8th or 9th at world level, so industry is fundamental for Italy. So when we talk about Industry 4.0, we need to state that industry is extremely important for Italy. Food industry, textile, footwear sector, the automotive, aerospace, shipbuilding, chemical, pharmaceutical sector, engineering works. And let's imagine some niches in which Italy is a world leader. Just think about tiles, tile making, eyewear, sun, glasses, coffee machines, without mentioning the large machines production. So here in the industry, we have a part of the beating heart of our nation. Industry weighs for 16% of the GDP. However, many services in Italy are associated to industry that would not exist if there were no industrial sector in Italy. So first element, industry is extremely important for Italy. The 500 billion euros of exports Italy has are due to industry. I will give you some examples and some elements coming from our observatory at the Politecnico University. We've interviewed many company managers of middle and large-sized companies. Interestingly, we can state that, first of all, over the 1 year and a half in which we've talked about this phenomenon, well, the phenomenon has grown a lot. These are the figures of 2016 compared to those of 2017. The rate of people who declared they didn't know anything about Industry 4.0 decreased from 40% to less than 10%. So there was an important effort carried out by the government, first of all, and then by industry, by research centers, trade unions. So a collective effort which led to a greater knowledge of the topic. So this is a first step towards the right direction. Then the second information element. We found in these 250 companies we've started over 800 applications. So we're not talking about a theoretical phenomenon. We are talking about a transformation, a digital transformation, which is underway. At least 3-4 applications within each of the companies we've analyzed. And so we are in the topic of Industry 4.0. The slide also indicates the areas in which we have the highest density of applications, especially those of Internet of Things and big data analytics. These elements are entering the industrial sector. Then there is another key element, the overall value of the market, 1.7 billion euros in 2016. This means that investments were made when it comes to specific technologies linked to Industry 4.0. And this tells us that investments are being revived after a period of halt. And these investments are also linked to other technologies which favor this Industry 4.0. Then, as I said, the important areas are big data analytics and Internet of Things. So to summarize, industry finally has come back to the core of our country. The knowledge of Industry 4.0 has grown a lot. There are many applications being used thanks to the plan for incentives carried out by the government. So we have started a cycle, a positive cycle, which needs to be supported for the future. Then the third passage, what can we say about the potential impact of this revolution on employment? Well, first of all, we need to acknowledge that there is an impact on employment, and there probably will be an impact on environment. This is a matrix which crosses two dimensions. It describes the working activities by considering whether they are intellectual or manual, or if they are repetitive or non-repetitive activities. The column of repetitive activities, manual and intellectual, is a column in which activities have already been attacked by the previous revolutions, I would say. So manual and intellective activities are already automated. And this is not an element which is linked to the current progress. That's not a novelty. The real new element is that even some activities in the column of non-repetitive activities, manual and intellectual, may be made automated. We should not exaggerate. The AI and some technological developments are very important at present. Yet, what we call artificial intelligence or robots, where they are very good at carrying out very specific activities. Only very specific activities can become automated. Tasks and jobs in general are made of an interrelation of many activities at the same time. So just a few jobs may be entirely replaced by automation. Yet parts of some activities may be replaced. Is this a positive or a negative aspect? Of course, it is evident that this will have an impact. And this leads to two kinds of questions. The quantitative impact in terms of reduction of jobs, and then a qualitative type of impact. What kind of work and jobs will remain for men? From the quantitative point of view, there have been many studies that attempted to analyze the situation. The figures highlighted are quite controversial. They are in contrast with one another. Reports were very good at estimating how many jobs can be lost, but it is very difficult to understand how many jobs can be created, and this is a real element of complexity, because it's necessary to strike a balance between jobs lost and jobs created. So from the point of view of balance, there is no convergence of answers. Instead, all the reports are consistent in stating that work and employment will be deeply transformed and quite at a rapid pace. So let's focus on the part of transformation of employment and the quality of jobs. I would like to give you a couple of hints, and these are taken for a couple of books. There are many interesting books on this topic. I picked two books. The one is titled The Second Machine Age, by Oxon and McAfee. Well, this is an interesting book. It tells us that the type of innovation that we are confronted with is an innovation which is proceeding and going on very, very rapidly. These technologies are exponential and combinatorial, and they self-feed. So we should expect a speeding up of the rapidity of change. And this tells us that the speed of change is quite significant. And secondly, they give several examples to show that there is a lot of complementarity between the abilities of man and the skills of machines. And so they state that it is useless to wage a war against machine. The real element is that of imagining possible ways to combine race with the machines. So you should run with the machine, not against them. Then the second hint is even more interesting. This is by another author, Nicholas Carr. The book is titled The Glass Cage, and he wishes to highlight a very interesting aspect. If in the history of man, technology has always been said as a potential increase of man to know reality, to enrich the body and the mind of man, some of the most advanced and recent technologies run the risk of placing man within a so-called glass cage. So detaching man from the reality and taking away the pleasure to experience reality. There are lots of examples, and I will only give you one. Evidently, the pilot of an aircraft is less capable of driving a plane than pilots of the past, because part of this work, part of this job has been taken by machines. So the underlying problem is that we need to be careful, because these advanced technologies are such. And do they put men in a glass cage, detaching men from knowledge, or can we use them as tools which increase the ability of man to penetrate reality? This is the underlying topic of this author. I'm drawing to a close now, and these last remarks are telling us that jobs will certainly be changed, and the way to use technology to achieve an evolution of work, an evolution of employment is crucial, hence the importance of training. We are talking about one of the variables that will enable us to dominate or to be dominated by the development of technology. From this point of view, it is fundamental that the governmental plan determines from incentives to training. And I've understood that this is one of the directions already stated by Minister Calenda for next year. I will close by quoting Pope Francis while he was talking with the workers in Genoa several months ago. Pope Francis said that the underlying topic is that there is an important technological progress, but we must be careful so that man is at the center of this change and not vice versa. Which direction do we want to go? Do we want technology to enrich the work, or do we want to use these technologies to have men be separated from work and from the satisfaction and gratification to work? Thank you very much for your attention.
Grazie Alessandro per questa descrizione.
Thank you, Alessandro, for this very, very informative presentation, very clear, that gives us so much information but opens so many questions too. So let us now consider the experience of a typical medium-sized company in Italy that works at a global level in the field of automation. It is a high-tech company which is investing in automatic driving. So now I give the floor to Giuseppe Ranalli. I always play a joke saying that my company is on the top of a hill overlooking the sea, so we're not really just about technology, we're also about living in the countryside. Well, let me thank my colleague that clarified so many points, as he also introduced the challenges involved. It is interesting to raise questions within such a very clear framework, because over the last few years there has been a trend to just make bold claims and to limit the content without helping people to understand and become aware of what is going on. We are an engineering enterprise. We design complex industrial processes in the automotive industry, and we have developed 200 patents on the innovative electrical engines. We are considering this challenge as producers of 4.0 technology from the point of view of the process and from the point of view of the product. And when I listen to debates, I always go back to my daily experience. It is interesting to notice that delocalization over the last 15 years, a lot of jobs have been lost in Europe. And why has there been such a shift to low-cost countries? Not just for low cost, because in complex industrial productions, there was also the opening of new markets, such as China. And the other reason was that the market was anyway asking for greater flexibility, because products need to be customized now. 20 years ago, technologies didn't really allow to produce a lot of products that were also customized. So greater flexibility was given by labor force. That's why there was this migration. And then the paradox is that over the last 4 years, these technologies mentioned by Professor Perego are causing a counter-migration, because the use of 4.0 technologies are really putting together a lot of other factors, such as improving products, no faulty products, and knowing more and more the behavior of parts of products. All this has put the basis for a new industrialization in Europe. So this is a factor that we want to consider first and foremost, because in those places where a lot of jobs had been lost, now they're being recreated and there's competitiveness. And Industry 4.0 is the result of competitiveness itself. What is interesting here is that there are risks indeed. Labor is indeed changing. However, at the same time, little is being done to become totally aware of this and to take advantage of opportunities. And I want to refer to the experience I have in what I see as opportunities, not just because I want to ignore risks. Risks are there, and that's why time should be used in order to take advantage of opportunities to the best and to govern this process. The real risk is that without being aware of what is going on and without taking on individual responsibilities, which is a great problem that we are having, that is, if we just rely on automation, then we have a huge risk. This process can be governed, it can grow, and we can take advantage of the opportunity. If we don't govern it, then there can be very big problems and damages to the productive system. So first of all, being aware. As the professor said, 4.0 puts together already existing technologies and integrates them and interconnects them. It is not something that can be bought on the market as such. In an inefficient productive system, if I do not introduce 4.0, I will multiply this lack of efficiency, so there is no automatic solution to problems. In the automotive industry, we have realized that these technologies can help us, and in Germany this is being done. They can help us create a full supply chain in the circular economy. Today, 73% of a car is linked to the cost of raw materials. So the competitive factor is not linked to labor force. The automotive industry is changing because electric cars are being now considered. And this is fundamental for autonomously driven cars. This is really important for the growth of the population and also the extended the life expectation. So these vehicles that can be driven automatically are really fundamental, not just to save in terms of resources, but also to take elderly people around who will be healthy. And we are very happy about this. We hope to be part of those elderly people that will be taken around thanks to these automatic vehicles. These technologies can contribute to the welfare system reform, such as the humanoid healthcare solutions that will really replace our carers. So it's interesting to face this challenge and learn how to live together with these machines and not just to fight against them. As I said, 73% of car costs are due to raw material. Raw material are scarce. Some of them will be over in 40 years' time. Our products are being produced better and better, so they last longer, so people may not change their products. So the end of the story is that 60% of the best raw material used in the for the car is not recovered, because the way cars are designed doesn't really allow for recovering most part of it. Even if there is a fast reassembly, if I wanted to disassemble a car today, 3 weeks wouldn't be enough to fulfill this operation. So the introduction of 4.0 technology is a helpful technology that, together with research, can really give us interesting results. Just consider how much research is needed to work on efficient assembling system, and also for systems to be able to recover raw material. This can give us a lot of competitiveness, because if considering net investment, we recover the 70% that is not recovered today, and if we can create a delta of 20-25 points in terms of competitiveness, so we can really have incredible results in terms of growth, with a 2-digit growth, and not just with decimal point growth. In the circular economy, if this can be applied, for example, in the automotive industry, but also in other sectors, this can be done, well, it would be possible to generate a supply chain with a reverse logistics that can generate a lot of jobs. However, a lot has to be done in research, and this has to be developed. So when we consider these assessments, let us be realistic and see what can be done, so that now we can start working to make this accessible to workers, considering all ages and considering retraining programs. Let us consider time to govern this process, because if these decisions are going to be made, it is up to us to decide how to do it and what to do, because if we just leave it to random actions, well, we may run the risk of facing dangers and facing chaos. What I see now is that today in our world we talk about these technologies, but we have no worry in terms of getting rid of people, but we see how many resources are freed when a lot of investments are made in human resources to study, to understand, and this is also what happens in big data and artificial intelligence. And this is interesting because there is a big transformation of products. We know very little about electrical systems. We do not know how an electrical car behaves. So all this really generates a lot of scientific work to find correlations, to generate knowledge. So let us dedicate time to knowledge, and this is a big challenge, and we need a lot of awareness, and I insist on this term, because this is not being considered in public debate. Those two schools of thought that have been, the three schools of thought that have been described by the colleague, are really causing a lot of damages, because they just distract us from the great job that we can do in order to increase more or to minimize the consequences that have always been present in history. Let us consider history. After the first industrial revolution, people have always complained about many things. We are now 7 billion people in this world, but there's many more employed people than there used to be at the beginning of the Industrial Revolution. When James Watt invented the steam machine, Europe really was in a terrible situation, because it was not possible to produce all the goods needed to meet the people's needs. But if we look at history, we should consider that without fear, the mind can be free and can consider reality much, much better. To conclude on the 4.0 industry, it is possible to work in real time thanks to these enabling technologies on a number of solutions that otherwise would lead us to get to knowledge just by means of experiments. For example, for an automotive plant, if we find out that a part has been designed badly, or we see that once a certain product has been launched on the market, there are problems. Well, thanks to simulations, and then Dr. Pontremoli will mention something about this. We do this in our company. We do dynamic simulations. We use augmented reality to speed up certain processes in terms of knowledge and to find out things in advance. This is a very important activity. It takes time, and skills are needed in this respect, very high skills. In order to have high skills, we should give everybody the chance to meet these desires. Then there's free people who may say, I don't want to grow, but no problem in that case. But these needs should be able to be met without trying to lower our threshold as we normally do in Italy. Something should also be said about circular economy. It is a really important concept because we cannot really continue our production using our traditional systems. There is a lot of resources that are wasted in this way. Industry 4.0 is also there to improve all this. There can be manual systems or automatic systems, but if it is inefficient in terms of cost and the economy, there's no point in using it. In the long term, cost-effective processes should be considered more. So I would stop here, and I would like to listen to Dr. Pontremoli and listen to his experience. Thank you.
L'industria 4.0.
So Industry 4.0 is an opportunity in general, and for individual enterprises, companies, well, it is also an opportunity for discovering what it can bring about. So companies should analyze the potentials and the possibilities offered by Industry 4.0 and then implement them to their own reality. So knowing the potentials and analyzing the market trends. So I now leave the floor to Andrea Pontremoli. He worked for IBM, and so he knows the dynamics and the evolution of IT systems. And then he moved and he started to work in a manufacturing company. So we're curious to know your opinion. Well, indeed, I would like to tell you a little bit how practically these concepts, which seem far away from our everyday life, are present indeed in our everyday life. So I will describe what our company does. I started to work with this company 10 years ago as a partner. So I became an entrepreneur after working for 27 years as a manager at IBM. And I will tell you a little bit about the transformation brought about in our everyday work by Industry 4.0. We manufacture racing cars. We are not well known, but we are the world leaders for commercial racing cars. So all the cars that take place, that participate in Indianapolis, Formula 3.5, not all but Formula 1, which is not a commercial formula, because it is owned by big brands. The Formula One US team is our own team, but we are specialized in racing cars, non-commercial racing cars. Well, in Dallara, to achieve this summary, to achieve this synthesis, it took 1 year. I went to Dallara and I started to ask, do we manufacture gearboxes? No, we don't. Do we manufacture tires? No, we don't. So all that we design is then manufactured using carbon fiber, because a racing car needs to be very light. So everything which is designed with carbon fiber needs several elements linked to productive processes, but also calculations on the structures, on the frames, which are very important. And in this case, we need to have to use supercomputers extensively. And then we also deal with aerodynamics. So the best shape of the car for the best performances and to have the best downforce possible. So the aerodynamic load. The racing car weighs more or less 600 kilos. As for downforce, we consider about 2,800 kilos. So the engine and the brakes, they accelerate and they stop. Well, the car behaves as if it weighed 3,400 kilos in terms of friction with the ground. And then we deal with the dynamics of the vehicle through the use of supercomputers, the study of the behavior of a car by using computers without manufacturing the car itself. I prepared a small video, 4 minutes video, and I will show the video to you, and you will have a chance to see in practice what my company is all about. So I will show you this video, and in this video you can see three things mainly. First of all, you will see some pictures about our territory. I am convinced that competition will be among territories and not among companies. This is a Lamborghini Miura, the first car designed by engineer Dallara. This is the castle where I live. This is the Bardi Castle. This is the road I cover every day to go to work. It takes 21 minutes to me, 22 minutes in case of heavy traffic, if I meet a bus. This is Dallara. Why am I talking about the territory? Because we, as a competitive advantage in Italy, have the territory. This is engineer Dallara. He will be 81 this year. He still spends the entire day at his premises. So the territory is extremely important with its infrastructure, with its educational system. This is the Varano racing track. This is the way we work. If you enter Dallara, you understand at once that you cannot design a car on your own. You need to work with your colleagues, and you need to work with the technologies. This is a carbon fiber. It is an extremely manual activity which needs super calculations before, but we need the hands of skilled personnel. They are craftsmen possessing high skills and high technological skills. This is the division for the dynamics of the vehicle. In this division, we carry out the tests before the cars are given to the customers. This is the division for computational fluid dynamics. So we use supercomputers to study the shape of the car. This is the model shop. The first 3D printing was installed in 2001, 16 years ago. So it's not a totally new technology. This is a wind tunnel. The wind tunnel is used to make simulations through a physical model of the behavior of the car And we do the opposite of what happens in reality. In reality, the car moves and the air remains halted. And in this case, we move the air and the cars keeps stopped. This is the professional driving simulator, which is the last element, the last division, and which is a synthesis of what I've said until now. In one word, it enables a pilot, a driver, physically to drive a car without having manufactured the car. So the pilot is actually driving mathematical models. Because innovation stems from mistakes. And through mistakes, in this case, I can make lots of mistakes with a very low cost, at a very low cost. All I have to do is change parameters in the software. So we solve the territory, the region, technology, and then the last element. This is our victory in the 500 miles of Indianapolis, the most important race competition of the world, 500,000 spectators, and this is the group, the team behind our victory. This is the real difference of our company. I've never seen an innovative company, an innovative business, with no innovative people behind it. So when we talk about Industry 4.0, we are actually referring to these people. These are the people who will use Industry 4.0. So what is changing in our world? And we're talking about high-performance vehicles. But first of all, we've started to change our way of viewing things. And we stated we no longer manufacture racing cars. We specialize in carbon fibers, aerodynamics, and supercomputers for simulations. These three things can be implemented and used in many sectors. We are now engaged in these tests and in these technologies for Ansaldo Breda for trains. We are working with Elon Musk for SpaceX, the missiles for space tourism in the future. We're also working in aerodynamics, and I will only give you one figure. We work a lot on engines to reduce consumption of fuel. Working on a car, I will not mention the name, but it's a car which costs 25,000 euros. Millions of these cars are produced. We've managed to reduce fuel consumption by 25% only by changing the shape of the car, and the final customer does not even perceive this because the shape seems the same, exactly the same as it was in the past. And the other aspect is the one related to simulation, driving simulation. This object, the simulator, it was designed by 14 young people. With engineer Dallara, we decided to manufacture this object on Christmas Eve of 2010. One of the features of Dallara is that engineer Dallara and myself are the owners, but we both receive the same wage. But all the profits of the company are reinvested in the company. We think this is the best way to increase our own value as a company. Our value is our company. So when you have millions of euros of profits, you have to decide where you're going to invest all these profits. If I were to tell you, you have 10 billion euros, you don't have to spend money going to Hawaii or to a casino. You need to invest them in a technology or in an enterprise, in a business. Where are you going to invest? We decided to invest this money in the driving simulator. It's an object which enables a pilot, a driver, to test a car without having the car physically available before manufacturing the car. In order to reach a prototype, in car manufacturing, we have 4 elements: the concept of the car, the length, the weight, the speed, the power, the speed it may reach. This is the concept of the car. Once you have the concept, you carry out a design So you design the aerodynamics, carbon fiber, the engine, and so forth. Once you have the design, you will build a prototype, and that's a third phase. I have one prototype, and then the fourth phase, I will test the prototype on a racing track, and I will see whether the prototype fulfills my expectations. Normally it does not, so I will have to change all the previous three elements, all the previous three phases. So in our heads, we took away the first two phases, the last two phases, sorry. I can have the driver testing the project. However, Industry 4.0 is a weird animal because it goes beyond what you had imagined at the beginning. When we brought this object to our designers, to specialists, everybody said it's nice, very nice, but you cannot, it's impossible to do because you cannot cheat the brain of a driver, making him think that he is traveling a curve at a speed of 250 kilometers per hour, when the driver instead is not within a physical car. So what did we do? We hired 14 recently graduated university students. They didn't know it was impossible, and they simply did it. And it was so successful that we managed to rank second in Indianapolis. I didn't take away the last two stages of the project. I also took away the third, the second stage, namely design. And this enables us to develop other concepts which were inconceivable. He talked about electrification earlier. So I need to design a hybrid car for my customer. Porsche, let's say it's Porsche. I have a gasoline engine and an electrical engine. Where should I place the engines? Should I place them one in the front and one in the rear? Is it better to have two electrical engines in the front part and the gasoline engine in the rear? Or should I have one engine, one electrical engine for each wheel? With the previous project, I need to have 4 prototypes, 4 designs, knowing that only one will be the one that is selected. If you work with mathematical models instead, I can simulate everything, test everything, and then I decide to design one thing because I know it will certainly work. And then the test on the track will only be the final confirmation of something which has proved to work beforehand. When we talk about the car of the future, whether it will be electrical, automatic driven, I don't know. But I can tell you one thing. I'm observing 2 lines which are opening up very rapidly. I'm referring to mobility. So I need to move. I need to go from Rimini to Parma tonight. And pleasure. The pleasure of driving, the adrenaline which a car can give you. We are blocked when it comes to adrenaline because you have speed limits to comply with. You have a hyper-technological car. The car is driving for itself. So we should go to the extremes. In this case, I will go to Uber. In 2 weeks' time, I will go to San Francisco, as you know, Uber. Well, there's lots of criticism in Italy because of the competition with taxi drivers. But Uber is changing the entire concept of mobility. So just think about it. I have my kid, and I need to take him to the tennis court. I call a car with my app, Uber app. I have a car at my house. My son enters a car. The car goes automatically to the tennis court. At the tennis court, I will have the tennis teacher picking up my son. I can call a car, taking my mother for a blood test to the hospital. Why should I drive? I can read the paper, and the car automatically will drive me from Rimini to Parma. So we're going to have a mixed concept of mobility. We're going to have a mix between aircraft, small or large cars, train. And then if I want to have fun, I go to the racing track, and I need to have a genuine car, a very fast car with no electronic control, because I want to be the driver in this case. Think about this object. Think about the mobile phone. Do you have any idea of the revolution that it brought about? We all have Industry 4.0 here. My mother is 86, and she made a very beautiful synthesis of the mobile phone and its technology. And she explained to me the success of mobile phones, of smartphones. She understood how it works. It is a thing which makes difficult things easier for you if you don't understand them. When you turn the light on, what do? You press the button of the light, and the lamp turns on. You don't care about the fact that there is a smart grid, a nuclear plant, that gas comes from Turkey or from Russia, then gas came, and then you use domotics. You only care about the lamp. And here, you have lots of buttons for the lights. I press this button. This is a stock exchange. It carries out complex operations, all the stock exchanges of the world, limited to the shares, to the companies I'm interested in. Do I want a car? I click on the Uber app. So Industry 4.0 is a way to simplify the life of final users by making very rapidly very complex operations. So I try to explain to you all the stages from planning, design, to the manufacturing. As for the making of things, we have lots of robots, we have lots of automatic operations that can be carried out. Think about one fact. As for racing cars, there's a new car, Formula E. All the cars are manufactured by Dallara, and so we always win the races. So that's an electrically driven car. About 5 years ago, I did not believe in an electrical formula for racing cars. They are totally silent. They are slow. The energy power of the battery is 10 times lower than that of gasoline. So with 300 kilos of batteries, I have the equivalent of 30 kilos of gasoline. When it comes to performance, well, it is not possible. I did not believe in it, but I told these people, I will carry out the design for you, but you need to pay beforehand. They did pay me beforehand. And then they told me, well, we have a problem. The battery only lasts 25 minutes. If you need to rush and to reach 300 kilometers per hour. So we needed to study something during the pit stop, not only to change the tires, but also the batteries. But batteries weigh 300 kilos and they have 600 volts. It's dangerous and it takes a long time. They wanted us to design a system for hooking and unhooking the batteries as rapidly as possible. And, well, an idea came to my mind. And I answered them, why don't we carry out a more entertaining thing? Instead of changing the batteries, we change the driver. The driver shifts the car. He will simply get out of the car with exhausted batteries and exhausted tires, and they will change car. So it's fun. Dallara will sell double the cars, and that's the end of it. So I found the perfect solution for the problem. Yet, I would like to say that the Formula E with electrification, which is a precondition of Industry 4.0, had one consequence I didn't think about. This gentleman drive a car, having all the checks, all the controls on board, but also outside the car. And what did they invent? They invented the contact with the audience, with the spectators. Alessandro, who is the chief of Formula E, quite an interesting person, he once asked me, do you know why our formula is successful? Because the car is silent, the race lasts less than 1 hour. So these two aspects combined enables me to have races and organize races in the centers of towns. And so the races can take place in Paris, in Los Angeles, in Berlin, and next year finally in Rome as well, in Hong Kong, in New York, Miami. So what happens? This Formula E is a talk of the day on the newspapers, and it is it is something which annoys many people because you block the traffic in these towns. But you can combine it with concerts, with lots of events. Let's go back to the smartphone. The 20 drivers engaged in the e-Formula were placed on Facebook, and so the fans, their followers, the supporters of these drivers, can place their likes to the driver they prefer. The driver receiving the most likes, will have 50 horsepower more for 15 seconds. The first race was in Shanghai. Prost was the leader, followed by Heidfeld. He ranked second. Who do you think got the most likes? The second one, because he wanted to see one overturning the other. The audience and this the driver has the driving wheel, which becomes green. And at the very last curve, the driver decided to use this extra horsepower. At the last curve, he starts to overtake Prost. Prost decided to resist, and in the end there was an accident, and so the third driver won the race. Think about the transformation. The audience, the spectators, got physically into the car and changed the way a driver carries out a race. So when we talk about Industry 4.0, we talk about all these possibilities, men interacting with other men, with the machines. We design a factory which is different. We think differently. But the key of everything, in the end, would be man, the human brain, the human being, with his intelligence, with his ability, and with his managerial abilities. The future managers will have to think about these things. They will have to be able not only to give other people the tasks they think about, but they will also have to be able to decide, as we did, to hire 14 university graduates. And we spent 10 million euros for the simulator. It was the profit of 2 years' work. And many people told us not to do it. But we thought about Christopher Columbus. If you go to Barcelona, there's a beautiful statue of Christopher Columbus pointing at the sea. And you can read the curriculum vitae of Christopher Columbus. Christopher Columbus had an idea. He wanted to go to India. He convinced the investor, the Queen of Spain, to finance the boats. Then he convinced his crew, the sailors. He convinced them to go on even in the point of no return. And then there was a boy who wrote on a graffiti. He wrote And if you think about it, Christopher Columbus had made a mistake. So innovation comes from the capability to open up, to work together, and not to be afraid. This is a very important opportunity for Italy. It makes no sense to simply state that innovation will take away jobs or will eliminate jobs. If we simply oppose innovation, there is no point in doing it. Italy is not 0.8% of the population, of the world's population. So Italy counts nothing. Italy counts in the world because we have brains, we have intelligence, and so maybe this Industry 4.0 will be the real key to enable Italy to be more and more important at world level. So this is my opinion. Thank you.
Allora, Ranalli ha già controllato se è vero il 0,8, ma
Well, our colleague have already checked whether this 0.8 is correct, and it is correct. Well, I really want to thank all the speakers for their presentations and for the time management. It was really possible for us to understand this potential of Industry 4.0, which is not something that should be stopped. It is a sort of revolution, and so its evolution is more or less automatic. It will very much depend on how we drive it, but it is impossible to stop these kinds of processes. I only want to ask one question, but I ask you to be very brief. The fact that this may make us more competitive is out of question. Then, everybody mentioned the importance of education. So now, in 2 minutes, not more than 2 minutes, otherwise I'll have to stop you, could you please give us your suggestions? Of course, you won't be exhaustive, but what would you recommend in terms of education and training that should be made to be ready to face these big challenges, these big changes? Education is obviously crucial to govern this process correctly, and the responsible for education lies on the individual. I don't think that it is the university, the research centers, but it is the individual person, the individual worker, and also trade unions. I found a very open trade union in this respect. So individual workers and then trade unions first, and then owners, company owners, then the top subjects in the supply chains that should be ready to invest. And also for the content of education, it's really hard to say something because it is so varied. Industry 4.0 has very different applications from sector to sector, so it's really hard to give specific recommendations. What should be done is what you mentioned before, that is to consider the features of each industry, of each sector, and then make a call on a responsibility that is individual. Then the government should also subsidize and invest in education. Thank you. Well, I agree, and in addition to this, I think that schools should be helped to get out of schools. Let us open companies, let us give the students the possibility to visit us, let's create programs that can favor internships and apprenticeships, systems and schemes where working and studying can be done at the same time, and we shouldn't be afraid of this. I realize that we as companies should be able to dialogue more in this respect and not to frighten schools. The Industry 4.0 is being developed so much in the food and agricultural industry, for example, organic productions. Organic productions with technology, sensors, cameras that can check on the level of maturation of fruit, and with tools that can harvest and can pick fruit and can be connected to the logistic systems. These are just examples. So there's no real sector in which there cannot be progress. So the more this can become familiar, the better. With education, we should really succeed in giving away this fear and try to be more open and ready. This is what we have done in the exhibition, for example, and this responsibility concerns us all, so let us help just going beyond all the obstacles. And Andrea Pontremoli this morning has had a meeting on this subject. Well, about education, I would say go back to the streaming of this morning conference as I presented my answer there with Professor Rabaglia. But what I can add is that it is true that it is the individual's responsibility, but there is also collective responsibility, and I mean also those present in this room and also the media, that is to give dignity to labor. As the Pope said, it is true that without labor there is no dignity, but my generation and my father's generation have made a lot of damages saying you should rather study, otherwise you go and get a job. Well, this was a disaster because we created a mindset whereby there is just either studying or working. And this is wrong because this is a collective responsibility. And I'd like to end on a positive note with some hope. I would like to mention Totò's poem entitled talking about death, saying that death is equal to everybody. So Industry 4.0 should be considered a sort of factor that can erase all the mistakes we have made in the past. It can give us the opportunity to rebuild our country. Thank you. As regards the subject of labor and dignity of labor, we will go back to it at 7 p.m. with representatives of the industry and the trade unions.
Mantenere vivo l'idea che il lavoro ha una sinistra.
Because really there can be no replacement of labor with other material things. Please remember to support the meeting with your donations. All these events need support, so if you wish, if you can, please just give your little contribution at the Dona Ora desks. Thanks to all of you, and I wish you a very pleasant evening.